Good to see you today, Griffin. How are you doing?
Hey, Kwabena, great to see you. I'm doing well.
Doing well. Thanks for taking the time to talk to me about the new OpenMV Cam N6. So we're launching this new system and we're kickstarting it currently. And so the OpenMV Cam N6 is our newest model of the OpenMV Cam that features an MPU on board. So it can actually run neural network models. This is awesome because now you're going to be able to interface a lot of the GroupGets sensors like the FLIR Boson and the FLIR Lepton with the OpenMV Cam and run models on board that thermal data. We're happy to have a partnership with GroupGets that we've been, working together now for, God, I think it's like 7+ years, right? At this point?
Yeah, most of the history of GroupGets.
Yeah. So can you tell me a little bit about GroupGets, Griffin? How did it get started?
Yeah, so GroupGets started about 10 years ago as a crowdfunding platform. That's where the name comes from, GroupGets.
Yeah.
And it's all about small batch hardware production, right? So GroupGets started initially so that our co-founders could crowdfund a Bitcoin miner, an ASIC miner.
I see.
And so those were super expensive at the time, and they wanted to get some money together to buy one. And eventually it just turned into this niche electronics hardware crowdfunding platform.
Okay.
And pretty soon after the start, our founder and CEO, Ron, had run into one of the higher ups at FLIR at the gym in Santa Barbara. And he told him that's where we learned about the FLIR Lepton. And since all the co-founders are engineers, they pretty quickly developed a breakout board for the Lepton. And made it accessible to more people.
Yeah,
So,
things took off from there, I guess, right?
Yeah. So FLIR just needed help marketing this new thermal sensor, since all their other products were for big industries and military applications. So it was great to get this small sensor to market.
Okay, and what are the specs of the FLIR Lepton and Boson for those who don't know?
Yeah, so they're both called microbolometers. That's a fancy word for a thermal camera. The FLIR Lepton is a small sensor. It's got a 160 by 120 resolution, but there is some image processing that goes on that makes it look much better than the resolution really is. The Boson, there's a 320 and a 640 resolution version. So the 320 has 4 times as many pixels, and the 640 has 16 times as many pixels. So the Bosons are much higher quality video than the Lepton. It's a big step up.
But they also have a much higher price, I imagine.
Much higher price, unfortunately.
Maybe we can get more people buying them so that price goes down. That would be great.
Yeah, I think it's scalable.
Yeah, so GroupGets has been selling the FLIR, Lepton, and Boson, and you guys are basically the only company on the market really that makes this stuff available in a hacker-friendly way. I think there's a few other different places that sell the Boson, but not really the Lepton, I think, except DigiKey and Mouser, I guess, or those are just you reselling on them, I think.
Yeah, well, so you can buy the Lepton sensor from DigiKey, but most of the boards that interface with the Lepton that you can buy there, those are from us. Yeah, we've cornered the market on development boards for Lepton.
For Lepton and thermal. And so you guys do something else also. You have this AudioMoth product, right?
Yeah, so this is really exciting. During the early days of the company, we started working with a team in the UK called Open Acoustic Devices, and they make the AudioMoth, which it's an acoustic data logger. It's just a microphone that wildlife conservationists put out into the forest, and they use it to study animals, listen for poachers. And it just happened to work out really well with the GroupGets model of small batch hardware production. Because it's like a seasonal thing.
A seasonal product, yeah. Well, it's been awesome though to work with GroupGets. I think from you guys, we collaborated actually on a project called the OpenMV PureThermal, and it unfortunately the timing of the product, well we launched it during the Kickstarter. I feel like we should get some visual aids here. I think it was a pretty neat product. Let me pull it up actually. Just give me one sec.
Yeah, I think I might have one.
Yeah, physically, I think I have one too. Let me just slide away from the. See if I can.
Have one right here.
I can't quite grab it from here. Yeah, so that's the OpenMV PureThermal, folks. And so this was our collaboration project working together with GroupGets. And more or less what we tried to build is a camera that can combine thermal and video data all in one. And so if I pull it up, I have a 3D view of it that I can go to, which would be pretty cool, I think, for people to see. It really is a it was the first time we tried to do something novel with combining thermal and thermal and visual data together. And so we were doing this on the OpenMV Cam. We basically took the guts of OpenMV Cam H7 and put them together and put a screen on it. And so it allowed you to actually overlay thermal data on thermal data on regular video data. And we had actually seen a few companies try to build a product like this, but the Kickstarter usually blew up with like some kind of the reasons for Kickstarters failing, typically not necessarily the hardware being bad, but like something else going wrong, and people didn't actually realize the product. But we were able to get it on sale and sell it. Just one manufacturing run. It was too expensive, and we also missed the I think the timing, right? Because of the chip shortage. We wanted it for the COVID camera, right?
It was a major accomplishment just to get this thing built because it was so hard to find components.
Yeah. So that was just a giant. That was a nightmare. But what was cool, though, I think, from it and the work we did together with this was, I had never used Altium before, and so working with GroupGets and Pure Engineering, who helped, who did the engineering for this, we really leveled up our game and being able to do like 3D CAD work and do this in the browser. I mean, if you check out our video right now, take a look at what we're doing, like zooming in on the camera buttons and everything. And so these kind of tools make it so much easier to engineer things, to be able to see what it looks like and then do all the 3D capture. So taking our learnings from this, we've really kind of brought that. We're looking forward to building more interesting projects in the future that combine these things. One such project that we're working on in the background actually is we're trying to go to a new combined module for the OpenMV Cam. And what we're going to do is we're going to combine thermal and color sensor data together and make this into a module that you can add to your OpenMV Cam. And so when we offer these kind of things, folks will be able to duplicate what we did at the PureThermal, but now at a much more affordable price. And that's our hope there.
Yeah, and I really like the idea of combining the thermal with the visible camera, because there are a lot of things that you just don't see in thermal only. Like you don't get sharp edges, you don't get really small details. And so if you're looking at just the thermal image, it's kind of hard to see, is that hot spot, a resistor on the circuit board, or is it, somewhere nearby? But when you have the overlay of the visible, then you can really see what you're looking at. Yeah,
and it definitely makes a huge difference. Or you can buy the FLIR Boson, but again, that's going to cost our
yeah.
But I think it does matter. Anyway, so I wanted to show you guys, show everybody a demo though of what you can do with the new OpenMV Cam N6 combined with a FLIR Boson, just to to show off what's coming up, for what everyone's going to be able to do. So I've got a FLIR Boson next to me. I'm just going to turn this guy on and get it to run. And so in this demo here, we're actually running YOLO V5 on board, and we are just oops, demo failure. Camera needs some resetting. All right, it's up and operational. Okay. So we've got the OpenMV Cam running on this board, and it's going to be running a YOLO V5 model. And so it's a little bit hard for me to move away from the microphone right now because I got my headset on. But as you can see, it's able to find me and detect me as a person using a YOLO V5 model. And so this is the new functionality that we're kind of bringing to the game now with these systems. So everything we're running on board is still a microcontroller, running MicroPython. But now we've got the ability to actually process thermal data and, you know, draw bounding boxes and run YOLO. This is the same kind of functionality you typically need a much stronger in system to run. Like you can duplicate this with a Raspberry Pi with the Halo processor, but that's a lot of hardware to add. And we've now got this in a very small form factor just with the N6 baseboard and the FLIR Boson adapter that we've launched.
Now, I'm more of a hardware guy myself, so I don't know much about software. Can you tell me a little bit about what YOLO is?
What YOLO is? Okay, so YOLO is an algorithm called You Only Look Once. What it's going to do is it basically looks at the image and tries to detect a set of bounding boxes that are located in the image. There's about 6,500 different bounding boxes it could possibly generate. And so based on that, the YOLO algorithm then, it's like a regression. It learns how to present those, you know, of those 6,500 bounding boxes. They can also be resized slightly. And so what it does is the neural network model is trained to present one of the, you know, it's trained to generate bounding box regressions from the image data that it sees. And that's how it's producing these bounding boxes around me and tracking me, as you can see. And so this will handle multiple people. Note that it runs a lot faster than 12 FPS like we're doing right now. That's just because the software isn't yet optimized and we haven't yet, you know, made to iron both fast. So the real performance is closer to 33 frames a second, actually. So just think about what you could do with that, Griffin.
Yeah, that's really cool.
Yeah, so we're excited to kind of bring this kind of capability to everybody with the new STM32 N6 and the new OpenMV N6. It's going to be awesome. I think a lot of folks are going to have a use case for this. Also, this model that we're using right now, this is trained on FLIR's OpenPerson dataset. So FLIR actually publishes a dataset of people, cars, trucks, and things that go, basically. About 16 to 20 different classes. And we took that data and with the help of Edge Impulse, we were able to train a model that could detect this. Right now, we're running the YOLO V5 Nano model, which is the tiniest one. But you can also fit a small model on board. There's 5 different types of YOLO models. You have nano, small, I guess medium or regular, large, and then like extra large. And so for microcontrollers, at least, we're only going to be able to work with the smaller nano size. And those ones being nano is like 3 megabytes or so. Small is closer to like 8 or 10 megabytes, and then medium is like 20. And then large is, you know, 40, and then extra large is like 100 megabyte models or so. So the size of the model kind of determines how good it is. You know, if you want the best performance, of course, the best accuracy, you'll go with the large model, but of course it'll run, it'll take eternity to run on one of these lower end systems like a microcontroller, or it would just be too large to even fit in memory.
And so the advantage of running it on a microcontroller, that's all about power consumption, right?
Yeah, it is. So we're drawing less than 1 watt of power for this whole demo. So the OpenMV Cam N6 with the FLIR Boson is doing, well, I'm not exactly sure what the FLIR Boson power draw is, but with a normal color camera, you're looking at about 0.75 watts, actually. So this means that you don't have any heat from your MPU or any other things like that. Now, if we switch it out, we can actually put a FLIR Lepton on board, and we can do the same thing. However, you're going to notice the FLIR Boson is much superior than a FLIR Lepton. So if you do have the pockets, try to get one if you can. I know GroupGets would love to hear that. All right, so this is the same demo running with FLIR Lepton. And you'll see that our frame rate's going to be, we'll give it a sec. It's still resetting the camera. It'll get there though. All right. So you can see the frame rate's not particularly great and the resolution's not great, but this is a, you saw it here first. This is a video side-by-side comparison though of the difference between a Lepton and a clear Boson. Which do you think is better, Griffin?
Oh, definitely the Boson. But you can get a lot of detail out of just the Lepton. Like it's pretty comparable.
No, absolutely. But I mean, this is where, I think having that combined thermal camera really will be cool, that thermal and vision, because then you could, overlay the thermal on the vision, and you can probably really increase the sharpness and quality. Obviously getting the overlay to be perfect will be somewhat of a challenge because it's distance related. If you think about it, two images, they're not the same, right?
Yeah, there's some parallax going on there.
Yeah, and it changes based on the distance. So if something gets closer, it's going to move farther away. It's going to the place where it appears in each camera changes based on the distance it is from each camera. So you get the best results from far away objects, but once they get close, it'd be hard to overlay those two maps perfectly, I suppose. Anyway, yeah, but I think this type of functionality is really going to allow for folks to build some, I think, pretty cool applications. I think the system just crashed there. That was great. This is demo hardware. Not everything's ready just right now, but we'll have it ready for everybody when everything ships. And so let's get back there. And I think if we turn off to Iron Bow, it'll run a little bit faster because the processor was doing a lot of work there. Yeah, so we get a little bit speed up. Yeah, it goes a lot faster now. That doesn't have to recolor everything itself. The way for us to speed that up, by the way, is switching to the GPU. So the DMA hardware and GPU can actually do that for the processor and do the recoloring. So it's a simple change in the code to leverage that, and then once we do, it'll go way faster. Anyway, lots of things to work on though for ourselves. All right. Well, I think that shows off our new cameras and capabilities. I mean, what do you think we can do with this kind of stuff, Griffin? Like what are you thinking about?
I'm excited. So thermal cameras have really big usefulness in fire safety. Right, you could put them in a kitchen, and it could sense when you walk away, forget the stove is on, right? And if you hook it up to a smart appliances, it can turn the stove off and prevent a fire. Or firefighters could use it after wildfires. There tend to be a lot of smoldering embers going on for days. Trees can even be burning from the inside, and you can't even tell. But with a thermal camera, people can go around and help put out wildfires. People detection is also a big one, and I think this is where the machine vision is a big deal. So like room occupancy sensing, you can make buildings a lot more efficient if you only heat the rooms where people are at. So using thermal cameras, you can count people very effectively in rooms.
Yeah, no, I think that's where a lot of our users have seen this kind of stuff be useful. I always tell people if they want to do something involving tracking objects, like try to do it with thermal cameras because it's way easier to see in the dark, which is very hard for a regular camera. Like doing things outdoors is much easier, and so on and so forth. I mean, when you mentioned like looking at food for fire safety or stove, one idea I've often had is could you use a thermal camera to like look at the temperature of food and build like imagine a stove where like you set the temperature on the dial, and then the thermal camera was like watching the heat of the pan and then like actually driving it to the right temperature versus it just being between medium, low, and high, which is kind of how every stove works.
Yeah, get some feedback. And
yeah, you could do that. But no, I mean, like, and given that we have a regular OpenMV cam, I think it shouldn't be lost on folks. You can attach a screens to the back of these, and then you could drive that using the Clear Boson. or a FLIR Lepton. So it is possible to build like, little thermal cameras or handheld things. That's kind of what we did at the OpenMV PureThermal. Now, a question: will we ever bring the PureThermal back with the STM32 N6? I'll say up front, probably not. We learned from our experience there that building such an integrated device is ill-advised. It's too much cost. But we might have something similar in terms of pieces, as we showed with the that mixed thermal and color camera that we hope to bring to the market. So it's all going to be fun. It's going to be cool, and you're going to be able to run neural networks on your thermal data and buy thermal cameras thanks to GroupGets.
Yeah, I'm really excited for this.
So before we go, Griffin, can you tell me a little bit about what GroupGets is working on in the future and what you guys have cooking up in the pipe?
Yeah, so we've got some exciting things coming soon. We've got an update to our old Boson HDMI board. So that's been out of stock for a long time, but we finally we fixed some issues, did some updates, and they'll be available pretty soon. So you can hook up a Boson directly to a computer monitor or a TV or an HDMI capture device to record with. So that's exciting. We've also got the Kimchi single board computer. This is
saw that. That's been cooking for a while, right? It's ready?
Yeah, so it was pretty expensive to manufacture, and we really had to gauge like is this ready to go to market? And we had a customer who had us build some samples for them, and so we just went ahead and built a batch of 200. So those will be available in a limited quantity pretty soon. That's a single board computer based on the NXP IMX8 processor. So
okay.
That's exciting.
Okay, and what are the cool features of the Kimchi? Just to let people know before we go.
So it's got these high density connectors. It's got a sorry, what's that called?
HDMI?
The
SATA?
SATA port. That's what it is.
Yeah, SATA port. Okay.
Yeah, it's got a SATA on it.
Okay, gotcha. So that'll be like a new embedded computer board device. What are they? Single board computer for folks to play around with.
Yeah, and we've also got some new stuff coming in the thermal space. We're working with an Australian company to distribute their new product. It's a new technology. It's in between thermopiles and microbolometers. So like I mentioned earlier, the Lepton is a microbolometer.
Yeah.
Thermopiles are another type of sensor. They're much cheaper than microbolometers, but the performance is also much lower. They tend to be pretty low resolution.
I gotcha. A microbolometer, so I believe it's a bunch of mirrors, right? Well, not a bunch of mirrors. It's a bunch of like circular discs that act as resistors, and the sensor is basically reading the resistance.
So each pixel is basically a resistor. There's an air gap underneath underneath it. So it's this microscopic air gap. The pixels are about 14 micrometers in size. And so as they warm up, the resistance changes. And because they're so tiny and there's that gap underneath them, they can change temperature quickly. And that's basically how the Boson and the Lepton operate.
Yeah. But what's a thermopile then? How does that work?
So a thermopile works like a thermocouple. You get two dissimilar metals, and like a thermocouple, you can measure temperature very accurately with that. You get a voltage generated between those two dissimilar metals depending on the temperature. So if you take that and make an array of those, you can have a thermopile array, and you can get an image out of that. Or they're common in stuff like PIR sensors, like really simple motion detectors.
Yeah, but I guess that's hard to manufacture at a small size, so that's why it's just not. That's why the microbolometer is how people are doing thermal cameras.
Yeah, you just can't get the image quality out of thermopiles that you can out of a microbolometer.
I see. And so this new Australian company is bringing something to the market that's going to be well. I mean, I don't believe thermopiles were ever cheap though. Also,
there's the Panasonic thermopile arrays.
Yeah,
they're
but
commercial. They're out there.
well, I mean, they were cheaper. They were still like $39 or so for like 8x8 pixels, which is still
Yeah. Compared to the Lepton, which is going down in price every year, or not every
Yeah.
year, but over time, it's definitely getting cheaper.
Mhm.
So these new this new technology is the company is called Calamino,
Okay. Well, I
and
think
they've got better resolution than
Lepton.
thermopile. So
The thermopiles.
it's supposed to be cheaper than Lepton, and lower power, but we'll see. We'll see. It's a work in progress with them, so
Okay. Okay.
that's exciting news.
Well, I mean, that sounds like a lot of fun things then coming up. We look forward to hearing more about these new systems as they come to market. Anything else you want to add before we go, Griffin?
I think I've covered everything I had on my mind.
All right. Well, anyway, thank you everybody for listening to our conversation. And just wanted to remind you that we have the OpenMV Cam N6 Kickstarter going on right now. And you can pre-order the OpenMV Cam N6 today via our Kickstarter. So please back us. Thank you for watching. All right. Bye-bye.